History-wise, he's been here a long time, about 3.5 decades. And he
started my undergrad in 84.
he started off as undergrad back in 85.
84, I came to Madison,
Yeah, 84. And I first met him when I came here, and the first time I taught 453, he was in the class.
It's
And-
gotten more handleable.
Then the first, yeah,
It was challenging.
I had a different.
We
well, I
spent
teach everything.
3 class periods on the radar equation that first time. We were like tornadoes.
Then, and then he was the first one at 718 when I taught graduate.
Yeah, that was.
So I known him for quite a while. He was one of the best students, so I actually had him join me as a graduate student. And he was my first graduate student along with Kathy. And Kathy Knack, for those of you, probably only you would remember.
Kathy who?
Knack.
Kathy Kennedy.
Knack.
Sure.
You remember?
Yeah.
Yeah, that's right. Yeah, okay. So, and so both of those, I think he was almost in the same office you are now.
I was right next door.
Right next door, okay.
Where I am now, yeah.
And he was a graduate student. He studied bomb cyclone type thing with the formation of gravity waves. We worked a lot with.
It was polar lows for my master's thesis, and it was the gravity wave for the stuff that I did. It was a postdoc position, but I didn't have a PhD.
We were collaborating with Pokrandt
Yes.
and Russ Schneider.
Yep.
Yeah. And it was actually Russ Schneider's study originally to look at this gravity wave that produced the heavy snow. And then and then Pete tried to do the modeling of it and worked on it. And finally he got something. But he really became a little disheartened with all the modeling. I think he went into it became a postdoc after that.
I never got a PhD.
But not a postdoc, but he became a researcher, full-time researcher for a while, and I don't think he was ever truly happy in that role. And during that time, we, at the advice of, what's his name from Washington? Battisti, yeah, Dave Battisti was saying we should convert a faculty position to a full-time support person for
computers.
For
That
computers.
was before me, though.
That was before you. And he said we should mortgage one of our positions, and we did. I think it was when Clark left from a state climatologist, and John probably remembers all this, how we did that, because I think you were chair at the time.
I think you guys converted a faculty line into this
Yeah, we
computer
converted
support.
a faculty line, and at least half a faculty line into this thing. And first we had Glenn Eklund, yeah, who was the computer guy, and then we had Ruth. Any of you remember Ruth?
Yes. Oh, yeah.
And then Ruth left, or I guess Ruth was leaving, but Pete, was looking at this and he was thinking, I can do this. And so Pete took over to become the computer person after Ruth. And he kind of worked, Ruth was kind of off and on, even while Pete started. And, what's that?
What's the Ruth?
You don't remember Ruth?
Ruth and Ross.
Ruthless Ross.
Yeah. She was a character.
Yes.
And, do you remember her, John?
Oh, yeah.
And then Pete took over, and he became the computer person. He's been here as a tech
Did I
person for the
screw something
department
up?
for a long time, and he's grown in the job and
18.
become quite an expert. So
Amen.
we're going to talk a little bit about the history and
We're going to talk about data.
about a lot of things. So that he's basically, a lot of you don't know all the things that he does. He doesn't just fix your computer when it's not working. He's more than that. He's even a national figure. He has talks at the AMS annual meeting every year. And they're at the point now where they invite him to come every year because he has a lot to offer.
I don't know about that, but
And he knows weather.
he's
And he knows weather. Yeah, that's one of his unique
difference
things.
between
He has a master's in atmospheric science.
So apparently I know weather, but I don't know what year it is.
Oh, yeah.
It's actually 2019, so. But I've been meaning to give this talk for a long time, so it could have just as well been last year at this time. I'm amazed when I run into somebody in the hallway and they're looking for some sort of data, and it occurs to me we have that here. Why are you looking on the internet elsewhere? We have it here, and the reason is I haven't told you we have it. Nobody knows it's here. So that's the main reason why I want to give this talk. We got some new hardware over the past year, and it's been kind of percolating, and I think it's now in a state where it's ready to use. So that's what I'm going to be talking about. Most of you are familiar with this sort of data, right? We look at this in WeatherWatch all the time. There's radar plots, there's satellite plots, there's the super peak upper air plots, but the plots come from somewhere, right? They don't just happen. There's actual data that's coming to make, that's behind this, that has to be plotted somehow. That's the data that I'm going to be talking about today. And ways to access it, what we have. For the course of the talk, this is probably going to be a discussion. I'm going to go through a little history. I'm going to show what the Threads server, I'll get to that in a minute, looks like, how to navigate that, ways of accessing the data, and then I'll show a couple of examples of actually live accessing the data. I'm probably not going to be able to get to everybody's use cases in terms of how do I do something specifically with a certain kind of data. This is more just to let you know it's there, and that if there is a certain kind of data, certain kind of access that you, particularly, yourself need or want to use, hit me up personally, and we'll spend half an hour and get it figured out, because it would take forever to try to do that here. So basically, I'm going to talk about the history of the real-time weather data here. Where does the data come from? How do we get this data? What kinds of data are available? How can I, meaning you, access the data? And then I'll show some examples. So we're going to go way back. Originally, when I started here, we were getting data. In fact, before I started here, we were getting observation and forecast and warning data over teletype. There was a phone dial-up to get data. There were fax maps. It was all printed out on paper. I've got actual examples if you want to see what they look like. But we got, surface observations that were coded and printed out on paper and kept in a file cabinet, basically. Upper air data, which was all coded. Anybody remember the TTAA, TTBB? Ed remembers, Michael remembers. This is where I get to do, anybody remember the old Saturday Night Live grumpy old man guy? Where he's like, when I came through school, we didn't have these fancy computers and these fancy gem-packed plotting programs. If we wanted an upper air map, we had to decode the data ourselves. We had to plot the data ourselves. We had to contour the data ourselves, and we liked it. Well, that's the way it was back in the old days. This is a radar summary. And again, I've got some of these actually up here. There's a whole rack of these in our workroom up on 14. So, going back to the radar summary here, this is what it looked like in 1984. That was my freshman year. I think I was actually here for that. Satellite, GOES E, right? That would have been GOES 5, I think. 1984, a paper printout of a fax transmitted copy of GOES E. These radar summaries came out once an hour, by the way, so you couldn't wait till the next one came rolling off the fax machine to see where things were going on.
Hey, can you still smell that fax map?
Oh, yeah.
I'm guessing after almost, 30-some years, it probably smells more like the cabinet than the fax fluid.
Until you burn it.
Right. Remember what it said, the electricity is in the ink.
That's right.
Yes.
That's right.
Pete, I think that's one of the first satellites, those satellites that had IR.
Okay. Yeah, I think you're right. I think the earlier ones were just visible.
This was a rain event in St. Louis. It was very disappointing.
Thanks, Bob.
Sorry.
I say that in a loving way. So anyways, around that time, we started getting some of this observational data over a satellite link instead of dial-up teletype. They were using a C-band broadcast, which as far as I can tell was a sideband on a lot of the satellite television. We had a dish on the roof and it came down, and still we were printing it out on paper. Around 1994, the company that we subscribed to get that data converted to a different frequency for their broadcast, which ended up a lot of universities and other places that wanted this data either couldn't afford the hardware that they needed to get the data, or there was terrestrial interference, there were things in the way, there was a cost involved, and a lot of the smaller schools were not able to make that change. And Unidata, I should have said this at the very beginning. I put Unidata's logo on my first slide. Much of what I'm talking about here today and much of what we do wouldn't be here if it wasn't for Unidata. Unidata is an NSF-sponsored entity that actually started here, right? Wasn't it Sumi?
First meeting was in 1984 here.
First meeting in 1984 in room 351 downstairs, where they said, we really need to make it so that universities, all universities and research institutions have either free or low-cost access to data and to software to plot that data. So thank you to Unidata. I just want to make sure to give them a shout out for everything they do. In 1994, they realized this was an issue, that a lot of schools were not going to be able to make the change. And the internet was getting fast enough at that time, and a software package that they had written called the Local Data Manager, which individual sites were using for managing data, storing it and filing and things like that. The internet was getting fast enough, they wrote parts of the Local Data Manager to be able to move data around across the internet. And their thought was, if we can have a couple of sites that have a dish to pull in this data, there could be a couple of top-level sites, they can send it using the internet to various other sites, and then basically everybody can get the data. So that happened in 1995. I guess I kind of said this already. When the internet data distribution first started, I tried to get some numbers because on the poster on my abstract for this talk, I mentioned we get about a terabyte of data, except I used a little b. So it's actually not a terabit, it's a terabyte of data a day that comes into this department through the internet data distribution system. And I wanted to kind of put that in context over the years. When I talk about the data's getting bigger and bigger, in the olden days, when the Unidata IDD first started, we were getting about a gigabyte per day. Everything except for the NextRed that we were getting, all the model data, all of the observation data, 5 to 15 megabytes per hour. And then they added NextRed, which was this huge bump. It's like more than double, 20 to 25 megabytes per hour of data. So it was on the order of a gigabyte per day in 1995. The data that we're talking about here came primarily from the National Weather Service family of services, which was a bunch of different teletype lines in the early days. DDS was basically U.S. observations, surface observations, upper air observations. PPS was the public product service, which is forecasts and warnings and other, not really observations, but like stuff that the Weather Service would put out. IDS was the International Data Service, which was basically observations outside of the U.S. And then there was this HDS, which was the High Resolution Data Service, which back in the day it was high resolution. It was model data, but by today's standards, there wasn't really very much on there. It was very coarse, very low time frequency, that kind of thing. 1998, a number of larger data sets came online. I did not realize, but Kraft was one of them, and Conduit was another. Those are actually acronyms. Kraft was the Collaborative Radar Acquisition Field Test, where they started distributing NextRad Level 2 data from all of the different U.S. NextRad sites throughout the Weather Service, replacing what they used to put it on 8mm tapes and send it around. Conduit was, there was a lot of much higher resolution model and gridded analysis data out there than what the high resolution data service was intended to send out and what a lot of places could handle. It was bigger than a lot of places internet pipes could handle. And so they started up this test conduit feed, Cooperative Opportunity for NCEP Data Using IDD Technologies, that some of the places that had faster bandwidth, including UW-Madison, were able to get these larger, higher resolution data sets, and then eventually, as some of the smaller schools caught up, they were able to get at that stuff too. NOAA came online around then also, where the National Weather Service started broadcasting a lot of the stuff that we were getting over the teletype and eventually the KU band to individual National Weather Service sites. And so a lot of the data that we started getting over the internet data distribution system was the stuff that they were piping out through NOAA, and that continues through today. So how much data was there? I tried to go through some older proposals and things to try to get an idea, because I didn't save any of this stuff, but back in 2000, 20 years ago, the conduit data feed peaked about 500 megabytes an hour. That was big, right? We had a 100 megabit per second network connection at Madison, so we could handle that. So it was on the order, the full conduit data set, if you add on the other side, no more than about 12 gigabytes per day. Just for comparison, I looked at just the other day, the conduit data feed now is peaking at 22,000 megabytes per hour. So we've gone up a little bit since 2000. Another data point, in 2006, we were getting borderline 25 to 50 gigabytes of data per day, and that was everything. By 2014, we're up to 13 gigabytes an hour for the entire data stream, or about 312 gigabytes per day. The big change since then is we've started getting the GOES 16 and GOES 17 data, which about doubled what we were getting. So today, our data feed for all of the different data that we bring into the department peaks anywhere between 40 and 60 gigabytes per hour and never really gets much less than that unless something bad happens. So you add that up and you end up with about a terabyte a day, and that's today. You know, it's going to keep getting bigger.
Does that include SSCC?
This is just the data that I'm getting over the internet data distribution. SSCC gets their own data. A lot of it, I think, comes in through satellite, you know, through the dishes on the roof and things like that. But a lot of the data that we get is sourced there. So, if that makes sense. This I just pulled off. They track how much data different sites get through the internet data distribution. And this is just one I pulled off the other day, showing the amount of data that we're getting from these various data feeds. And I'll talk about what these different data feeds are in a minute. But you can see here we're peaking at about 75 gigabytes that hour. So it's a lot of data. Here's just another one. The satellite data feed, which is where we get our GOES 16 and GOES 17 GRB data. That's peaks out at the biggest, about 16 gigabytes per hour. NGRID is a bunch of model data that we get over NOAAPort. That's close. So the whole thing, we get, there it is, roughly 75 gigabytes per hour peak. So it's a lot of data. So where does the data come from? How do we get it? It's this UW Internet Data Distribution Project. Basically, for these different data feeds, there is a top-level site where the data originates. Then there are a number of lower-level sites that pull data using the LDM from that site and then broadcast it on to other sites, which may not want all of the data until you get down to the very bottom. You know, some of the community colleges and places that don't have really high-speed internet might not be able to pass data on to other people. They're just at the bottom of that tree. We've been a near top-level node for just about all of the data streams going back to the beginning. So pretty much any of the data that's out there we have access to, and we pass it on to, you know, a dozen or more other universities as well. These are the different data feed types available and the kinds of data that are on them. The DD Plus and the IDS go back to where I was talking about the family of services, where we had the domestic data service, international data service. Those are all observations and text. HDS is the not as high of resolution anymore, but binary data. Conduit and NGRID are also mostly NCEP model data. GEM is the Canadian forecast model, and the FNMOC is the Navy, various Navy models, and all of that data is available on the server I'll be talking about in a minute. We get all of the NextRed Level 2 and NextRed Level 3 data, which is also available on a number of different feeds. The FNexRed is a floater NextRed feed where they generate some composite data and some floater sites for sites that don't want the entire feed of data. And then for satellite imagery and other data, there's a satellite feed, which is the GOES rebroadcast data. N-image is NOAAPort sourced GOES 16 data and 17 data. N-image is older satellite, GOES 15 imagery. And other is the GOES 16 and 17. And then the UNIWISC is something that's sourced down in SSCC that has satellite imagery and some other data, mainly for Mercatus users on the end. And then the National Lightning Detection Network has lightning data. That's basically just, if you hear me talking about a certain data feed that we have something on, these are the various ones that are available. You don't really need to know that to be able to access the data on the Thread server. This is just kind of background on where the stuff comes from.
Pete?
Yes?
Lightning data, can anybody get it?
The lightning data is restricted. We can only pull it from Albany, and it comes from, I forget the company that that sends it out, but it is restricted for education and research
Vicelab.
purposes. Vicelab, thank you. So if you go to our website, you notice you can view that from within our department, but if you go home, you won't be able to because it is restricted for.
Can you
only-
use it?
For education and
Yeah.
research, yes.
Okay.
Can you use it for the state climatology office if there's a lawyer looking to see if lightning struck?
Yeah.
Probably not. That would probably violate the
Climatology of
agreement.
severe storms.
Huh?
Climatology of severe storms.
If you wanted to
yeah.
write a paper on climatology of severe storms and there weren't lawyers or, something like that involved, you probably could, yes. I mean, it's intended to be used for research and education. So if it falls under that umbrella, you probably could use it.
Will the ability for the GO satellites to detect lightning, will we be able to get that data?
Yes. In fact, we are getting it. I don't have it on the Threads server yet, but I know Unidata does, so I just need to figure out how they're doing that and add it to our server. But that's, it's a different, the GO's lightning mapper is a different way of detecting lightning than what this stuff is. The National Lightning Detection Network, if you ever listen to AM radio and lightning strike happens and you hear it go, there's a number of antennas around the country that basically triangulate those signals and figure out where a lightning strike happened, how strong it was, what the polarity was, stuff like that. That's the data that's in the NLDN feed, and that's done by private companies, and the data is restricted. The GOES lightning mapper uses a completely different method of detecting lightning. It basically looks for the flashes and is able to, through a bunch of processing, determine things like, how many lightning strokes were there and how much, what was the aerial density. There's a bunch of different parameters. It's a different kind of data, and it's probably not. You probably can't use it in the same way that you would this data, but it will be available at some point. So again, this is you've seen this graph already. This just shows some of the different data feeds that I was just talking about. Generally, the satellite data feed is the biggest. Some of the binary data that we get over NOAA port comes in second. This is also satellite data, so all of this pink and yellow here is GOES 16 and GOES 17 data. And then all of the rest of the stuff, like here's NexRad level 3, NexRad level 2 is a little chunk. So, lots of data. So, how can I, meaning you, a user, access this stuff, right? Historically, what we've done is we've filed that data on a weather server, weather.aos.wisc.edu, and we've made those directories available using NFS to the 14th floor classrooms or other computers of interest within the department. I know a lot of the different faculty research machines have access to this data as well, or anybody in the 1411 lab. And the weather data directory has real-time stuff, and then the weather archive directory has some archive data. Most of it is in GRIB format or GEMPAC format or Genie format for satellite imagery. There's some NetCDF. All of the new GOES 16 and 17 data is out there in NetCDF format. Typically, to access that data, you have to be on one of the machines connected to our that has that particular data directory mounted on it, and use something like GEMPAC or something else to plot it. And that's how we've done it in the past. I'm not stopping that. So John, you're okay. You can still use GEMPAC for a while.
But what do you mean a while?
Well, the weather service doesn't support GEMPAC anymore.
Okay.
They're using AWIPS now, which I'm not going to talk about. That might be another talk if we end up with a slot later this spring. I may talk about AWIPS. I have to figure out how to use it first. So they're not using GEMPAC anymore, and Unidata is supporting GEMPAC. There's some GEMPAC under the hood of AWIPS. And as long as they continue to support it, I guess we can try to continue to make it available. Probably you'll be able to retire and still be using GEMPAC.
That's all I was looking for.
Yeah. So, but we're not going to talk about GEMPAC today. We're going to talk about a new way to access data. It's nice for a number of reasons. You can access it from anywhere. You can access it not just using GEMPAC, but using a number of other tools. Within the Threads server, so Threads, I forget what it stands for, it's an acronym also. Threads is a software package, it's a web server written by the folks at Unidata, sitting on top of Java, so it can be a little slow. Anything that's written on top of Java can be slow. But it has some really nice features. It can basically hide the data and what format it is from you and present it to you in a common way. You can subset the data by, you can have one file that has the entire GFS forecast out to however many hours it goes, with all of the levels, all of the variables, all of the globe, quarter degree, and you can say, only give me the 500 millibar temperatures at the 60-hour forecast over the North Pacific. And it'll send you just this little chunk of data without having to pull the entire data set out. There's a number of different ways you can access it, and the rest of my talk is basically going to be showing you how to do that. So I'm going to pull up the thread server and just give you an idea of what it looks like. So this is live. This is, I'll try to zoom in on that a little bit. We've got Bucky in the corner, so you know it's us. Bucky with the lightning bolt on. They haven't told me not to use that to my face, so it'll be out there. So this is what the thread server looks like, and this is the catalog that the thread server presents to you of the various kinds of real-time data that we have. The top link is forecast model data. That has links to GFS, the NAM, the HER. Well, we'll go in there and I'll show you. That's basically forecast model data. There are some other forecast products and analyses. You may have heard of the MRMS, the multi-radar, multi-sensor analysis. That's out there. The real-time mesoscale analysis is out there. Some other stuff. Observation data, this is interesting. If you go in there, there's surface and upper air data. If I can get to it. That's interesting. It worked before. Let's go over here and see what happens. Hold on.
This looks like my
It's going to work. If it fails, I can always do it over on your computer also. It wouldn't be a live demo if you didn't have some issues like this, right? Okay, so here in the observational data, we have surface METAR, ship and buoy, synoptic, upper air, and some test buffer data. And if you go in here, lo and behold, yeah.
You can also just add that this isn't just data over North America, this is the entire globe.
Correct. Yes, well, it depends on what data set you're looking at, but a lot of the data is global. And you'll notice on here, all of the surface and upper air data are GEMPAC files, which is interesting because I just said we're not using GEMPAC anymore, right? There's some issues with point data sources that most of the data that you get from a thread server comes to you in NetCDF format. There are issues with point data sources that there's not a really good way of representing point data sources in NetCDF format. And so what the thread server will do with the surface data, it'll actually take the data from the GEMPAC files, package it up to look like a NetCDF data file, and return you the information in that format. There are issues with that with the upper air. So at this point, the best way to access surface and upper air data is probably use the thread server to download the file and use GEMPAC to do something with it at that point. They're working on that. The unit data folks are aware of that limitation, and they're trying to figure out what the best way to get around that is. But so we've got model data, model analyses, or forecast products analyses, observation data, radar data, which is the level 2 and level 3 stuff, and some satellite data. So let's go into the forecast model data and just take a look at what's in there. We have the GEFS data, analysis and forecasts, and some derived stuff. GFS data at a number of different resolutions. This is quarter degree global, and you can either get just the analysis, which is the times 0, or you can get the entire forecast up to, 384 at quarter degree resolution. If you don't need the quarter degree resolution and you want something that's a little smaller and a little more manageable, they also have the half degree and the 1 degree stuff. These data sets are available. I think I keep those by default for 2 weeks. So any GFS run within the last 2 weeks is available to you on there, all of the different 6-hourly runs. A number of other GFS data sets, some subsampled stuff, 40 kilometer over the Pacific. I won't get into all of what these are, but a number of different subregions of data as well. Here's the high resolution rapid refresh, the HER, that data is out there. All of this stuff is available for 2 weeks. The NAM on a number of different grids. Probably the highest resolution is the 12-kilometer stuff, and there's different grids. We get some NAM stuff from the NOAA port data feed, and we get some NAM stuff from the conduit data feed. I think the stuff on conduit is more complete. There's a lot more information out there. Because the stuff on NOAA port, it's really intended for weather service forecasters, and they don't necessarily need everything, whereas you as a modeler might want access to everything. I think that has more, but then there's a number of other sub-regions as well. The rapid refresh, the short range ensemble, and the Wave Watch 3. I don't even know what that is. I'm not even sure I haven't looked at it, but that's there if you're interested. The Navy model at half a degree resolution, global, their Wave Watch model at 1 degree resolution, and then the COAMPS model, which is available over different sections, Western Atlantic, Europe, and a number of stuff out, a bunch of stuff out here. So that's basically what's available for model data.
Hey, Pete,
Yes.
I think the Wave Watch is actually ocean waves.
Okay. Yep.
Probably statistics of
It's
that.
it's a forecast,
No,
it
it's forecast.
involves a forecast.
Yeah.
Okay, so I'm gonna, just for the fun of it, go into the COAMPS Western Atlantic time series, and let's go to this morning's 12Z run. That's the file that it's gonna pull data from, and if you click on that file and drill your way down, you're presented with a screen that looks like this, okay? This is a list of a number of different ways that you can access the data. OpenDAP is a way of accessing the file as if it were a NetCDF file, but without actually downloading it. So you can open the file remotely, and it won't actually grab any data until you actually ask for the data. But you'll get the information about the file, all of the variable and coordinate information that's available right when you go into it. So for example, let's just go there. Here's the URL that you would use to get to it. And there's just a bunch of the information that comes from the NetCDF file itself, but I haven't actually downloaded any data yet, so it's really fast. So you can dig through there. I'm not going to talk about some of these other ones because I don't really use them. DAP4 is it's a newer version of OpenDAP that some software might use. The HTTP server is basically just a file download. So if there's a file out here and you just want to grab the file, archive it for yourself, or you just feel more comfortable having the file on your machine, you can grab the file that way, and it'll just download it. Just click on that, and it'll download to your computer. NetCDF subset is the one that we use for grabbing a piece of the data. So if you only want, one time, one level, one area, you can do that, and you can actually go in here and generate a subset. So this shows you the area that the data covers. This is basically, you can type in the bounding box of where you want the data from, what variables you want. They're all listed on the left here, different types of variables, so you can go through that. It generally helps to add the lat long onto it so that when you get it into your program, you know where it is and you can actually map it. You can tell it what level, if you want all of the times or just one. And then at the very bottom here is it'll generate this URL from your selections, and you can basically put that in your OpenDAP request and it will get what you've asked for. And I have an example of that. I'll show you a little bit about that in a minute. So those are the various ways that you can get at the data, and these basically exist for all of the data on the server, right? You go to radar data, you'll see a similar set. Go to the GOES 16 and 17 data, you'll see a similar kind of thing. One of the things that's kind of cool on here is there's a preview section. It'll actually generate a Jupyter Notebook that accesses this data in a certain way, and I'll show you one of those in a minute as well. And it's real simple. It basically just says, okay, grab the data and draw a simple plot. Don't do any scaling, don't put a map on it, anything. But it gives you an example of how to access the data, and once you've got the data, you can do whatever you want with it. But there's also this Godiva browser-based preview that you can actually go into and get a real quick look. So like, let's say we want to look at, I don't know, latent heat flux near the surface. There's a plot of that variable from that data set. Terrestrial height surface should look kind of like a terrain thing. And so basically, you can't see it on here because of the size of the image. But there's actually something off on the side where you can change certain things. You can do contours if you want instead of colored. It's just a real quick and dirty way of interrogating the data set for something that may not be available where you normally look at the data set, right? Maybe you want to look at total precip at the surface. Looks like there is very, very little maybe in here. But you can do that for any of the data sets that are out here. So if you just want to do a real quick interrogation of what does this variable look like, you can just do it in your web browser from wherever you happen to be, at home, whatever, for any of the stuff that's out there. I should say, I don't think this is working for the geostationary satellite data yet, and I need to talk to the unit data guys about that. But that's kind of a cool thing when I discovered that you can just quick from a web browser pull up, it's pulling the data from the file as you click on it. So
Are there additional specifications? I noticed there was isobaric temperature and so on. You'll have to specify the temperature of the
Yep.
isobaric level and stuff?
Yep, so let's go and do that. Real quick. So we're in here.
Yeah, I think it was one of the top ones.
Right, yeah, you have to click to expand the data set. So air temperature, isobaric.
Oh,
And
yeah,
here it
okay.
tells you, these are the different levels that are in the data set. You click on the color bar, you can change it to a different color palette. I mean, there's lots of, again, it's a quick and dirty way of looking at the data. But one of the really cool things is, let me go into the geostationary data real quick, because I'm gonna run out of time on, well, I guess I'm doing it right. Just real quick, what does the radar data look like? Here's level 3 radar data from the NEXRAD, from the terminal Dopplers of the airports. Level 2 radar data, and then some composite stuff that's available from unit data. I'm not gonna go through all of this stuff. You can just poke around and look at it at your leisure. I guess I didn't get into here either, the forecast products and analyses. Here's the National Digital Forecast Database. That's kind of fun to look at because you can see the different individual forecast National Weather Service sites and their regions of influence, because they don't always match up at the boundaries. You can kind of see where they are. Real-time mesoscale analysis, the multi-radar, multi-sensor analysis in terms of radar, compositing, and things like that. That's what's all in there. And then with the geostationary, with the GOES 16 and 17 data, that's under satellite data. All of the GOES 16 and 17 data are under this first link. There's some other stuff, older GOES 15 imagery under a lot of these other links down below. But if you go under GOES 16 and GOES 17, there's 2 sets of data for each satellite. The GOES 16 and GOES 17 on the top are the net CDF files that we get through NOAA port. And they come through NOAA port tiled in different smaller chunks for each image. Those are all reassembled and in here, and the data that you actually get from these, and there's different regions available at different times. The quantity that you get if you go into one of these data sets is something called, and we won't be able to actually preview it, but I can show you what's in there. It's something called sectorized cloud and moisture imagery. So basically, the satellites measure radiance, right? And that's what actually comes through in the GRB data files. For the NOAA port data set, they actually convert that into a reflectance and a brightness temperature, depending on if you're looking at visible or infrared data. So these files actually have that brightness, temperature, or reflectance in them. The files in these data sets on the bottom, whoops, this one, the GRB 16 and GRB 17, those are the GOES rebroadcast data, and those files, they have radiance data in them. So if you want to look at them as if it were a reflectance or a brightness temperature, you have to make that conversion. One of the examples that I have actually does that. The other difference is for the NOAA port data, they resample the full disk imagery, they downgrade it to 6 kilometer resolution. So all of the other sectors on there, if you go to the CONUS or the Alaska or the Hawaii region, those are all full horizontal resolution data. The full disk imagery is all downgraded to 6 kilometers, so it looks pretty crappy if you look at it. The GRB data is full resolution data. So you can go out there, and again, this is where, like the global lightning mapper and some of the other geostationary, some of the other GOES 16 and 17 instruments will appear in here once I figure out how to make them work in threads. But this data is actually full resolution, half-kilometer global data. We can go to today. I don't know if a preview is going to work on this. But it should be, let's see, 2-kilometer resolution. So that visible image is 21,000 pixels by 21,000 pixels. I don't think they have monitors yet that can show that. I mean, that 4K is not quite that, right? But, okay, so that's the thread server. You can poke around and look at it. In terms of actually getting the data on that, accessing the data on it, there's a couple of different software packages you can use. One of them is called the Unidata Integrated Data Viewer, another Unidata product. I'll show you just briefly how that works. It's been around a while. It runs on Java and it typically is very slow, but it works and it does, you can do Viz5D kind of stuff in it. And then there's also with Python, there's a really slick NetCDF interface that you can query and access this database or the threads, the data on the thread server as well.
The IDV is actually Viz5D, right, initially. It comes from VizAD,
Kind of.
which is
Yes.
what.
So let's do that. Let's go and fire up the Unidata Integrated Data Viewer. It's available for Windows, Mac, or Linux. Go to unidata.ucar.edu, look under their software page, and you should be able to find it. Don't taunt it. Wait till it finishes coming up or weird things happen. So, okay, so now we have the Integrated Data Viewer up and running. Let's go to the data chooser, not that one, right here. Let's go to a catalog, and I've typed in the URL for threads.aos.wis.edu for the forecast model. So you can see here is the same list of models that we had looking at the thread server itself. Let's say we want to look at, I don't know, the HER. And we want to look at the HER from NCEP, and we want to look at, let's look at the full model run. And we'll look at the most recent full model run, which is 18Z. And we'll take that one and we'll add that source to our data. Now we have access to all of the quantity. Again, it hasn't loaded any of this data yet, right? It just has the information about what's in there. Let's say we want to look at, for example, a derived quantity. Let's look at the wind speed from the isobaric data, and let's not do the whole data set. Let's just do part of it because it'll take too much time. But let's look at the first 6 hours of what that looks like. And let's do a 3D surface, ISO surface, and we'll hit create display. Now it's going out and actually pulling in the data from the thread server. So just the data I asked for, the U component and the V component of the wind at all of the levels because we're doing an ISO surface. And assuming it doesn't take super too long,
Is that for a full geographical grid?
No, the HER is, I think, just over the continental U.S., but you could do the same thing using the GTFS globally, yes. It depends on the region that the data is actually.
You could
defined
focus on mainly Wisconsin.
What's that?
You could focus on Wisconsin or
You
something.
can, and we will. So here you go. Here's a Viz5D-ish. It looks like it's still rendering the images, but let's see if I do this right. No, we're going to zoom now. So that's the keys. I'm not used to the keys on this, but it's not it.
I don't remember you choosing a value. Did you do that somewhere, Pete?
I did not. It shows
Is it
up, if you
default?
go in here, you can tell it's
32.9.
32.9.
Oh, yeah.
Pick one, I don't know, 40.
So that defaulted to 32.9.
It just picked a default, right?
Quite logically.
And again, I don't use the integrated data viewer much. I'm not really familiar with it, but I know sort of how to make it work. It's pretty cool. You can do a lot of stuff with it. You know, this again, it'll run at home, and you don't have to download an entire data set to look at it. So that's the integrated data viewer. It works with model data. I haven't tried it with satellite or other data, but we could. I'm not going to do that right now, though. Because what I want to show you is the other part of our new infrastructure. In addition to the thread server, I also got some money from an ILM grant last year to set up a Jupyter Hub server. What a Jupyter Hub server is, how many of you have heard of Jupyter Notebooks? Anybody who's in Petty's class has used Jupyter Notebooks. A Jupyter Notebook is basically kind of an integrated data or an interactive development environment that you can use Python. It also runs other languages, but typically we use Python on it. A Jupyter Hub basically allows you to log in through a web browser from anywhere and fire up a Jupyter Notebook or multiple Jupyter Notebooks. Our Jupyter Hub is https jupyterhub.aos.wisc.edu:1225, like our address. You have to be on campus to access it, so if you're at home, you need to run WISC VPN, but it does work. When you first log in, into the server, it looks like this, and basically log in using your, anybody with a login in the 1411 lab can access this. So I'm going to log on as me, and when you first log in, you'll have a list of all of the files in your home directory and the 1411 server. I've got a ton because I've been here a while. These are all various Jupyter Notebooks that I can open. I've got a couple of them that I set up as demonstrations for today. You can also get at, let's see, I don't want to make a new folder. What am I trying? Let's see. A new, you can actually get a terminal on here. So within there you can get a command line terminal, which is basically just a Unix prompt that you can get at. So if you need to move data into or out of the Jupyter Hub server, you can do that there. And it's basically your home directory on the 1411 lab, right? So whether you're on one of the cat machines or one of the machines in 1411, this is your same home directory. Here is the Jupyter Notebook. This is some Python code that I have that will query the threads server and plot a analysis of the sea level pressure over the North Pacific for, I forget what day it was, but it had a pretty nice low. So this is the top. It's importing a bunch of stuff to allow me to do that, just expanding on what the base Python is. I'm going to grab a catalog from the top of the threads server. If I print that out, it just says hi in the thread server. Do some other magic. These are the various data sets that are available. I'm going to tell it to grab the third one, which is the GFS data set. I'm going to import some time stuff so that I can set what time it is. And I can make example notebooks like this available to people that are not familiar with Python at all. I'm going to tell it to grab the data from February 11th at 12Z from 2019. I got the date right there. So I'm going to have it send me what data set is that one. There it is. It's going to, I'm setting up the NCSS, the subset data. Here's a list of the various variables that are available in there. It takes a little bit of work to put something like this together, but once you've got it, you can query the data, specify the lat long that we're going to plot on, tell it we want sea level pressure, set up some mapping, set up a figure. That is basically starting to plot the figure, and here you'll see a map of the North Pacific where I'm going to plot my data in the notebook. And then what I do is some fancy stuff here to plot certain colors. I'm going to plot between 1004 and 1060 millibars in black, and I'm going to plot from 900 to 1004 in red. And we'll go ahead and set up those contours, and then we'll regenerate the figure. And there's a nice low in the west of Alaska for you, John. I did that for you.
Thank you, that's nice.
So basically that just went out live right now, talked to the server, said give me the sea level pressure. I only need it over the North Pacific. It's from the, I think it was from the quarter degree, and that was pretty quick. So there's an example. Here's an example. Similar, querying the server and getting the most recent GOES 17 channel 13 data. Again, I'm not going to go through all of the details of what this is all doing here. This should look a little familiar. These are the same access methods that we saw when we hit it from the web server, OpenDAP, CDM remote, blah, blah. We're going to tell it to pull it in using OpenDAP. I'm going to grab the file. What file is it? It's a .NET CDF file. Here's a bunch of metadata that comes in from the netcdf file. I haven't actually gotten any data yet, right? It's still been pretty quick. I'm going to tell it to grab the radiance data and some other things that I need to convert the radiance data into brightness temperature, and we'll go ahead and do that now. So now it's grabbing the radiance data and doing a multiplication or running it through a formula to turn it into a brightness temperature. We do some navigation stuff, set up a map, create a figure. At this point, it basically just shows here's my region that I'm going to be plotting. It's basically the whole full disk. Matplotlib. This is setting up a custom color map that I'll be using, and this is basically the one I use on the website for coloring the brightness temperatures a certain way. Create a plot, put some coastlines and state boundaries on it, put some color bar axes on there, and then redisplay the figure. And now, if everything goes well, we should get a full disk picture of the most recent IR channel 13 from GOES 17 that we just pulled in the data just right now. And then I've got some other stuff on here in terms of putting a label on there as well. So that's from 21Z, 20 minutes ago. So that's the kind of stuff that you can do with it. I didn't show you, let me go back to the Threads server. One thing that I just discovered recently, and I think this is a new addition to Threads, if you go into any one of these things, let's go just in the GOES 16, the ABI data from CONUS, any one of these, pick a channel, pick a time, whatever. Doesn't matter, we'll get a data set. One of the options in here is the Jupyter Notebook. Okay, and if you click on that, it's going to download a file to your local machine, which basically is a Jupyter Notebook that's all set up to access that data file from the Threads server and draw an image. So I'm not going to use the one I just did because I have to move it over to the Threads server. But here's one that I did yesterday, okay? I've got, this is what it'll look like if you open it up. There's a couple of prerequisites that you have to have installed. They're already installed on our Jupyter Hub server, so if you log in there, this should just work. But basically it comes down, it imports something called Siphon, which is another unit data product that's intended for pulling data from a Threads server. It's a data catalog. That's the particular data set that I asked for the catalog for, or that I was in when I asked for the Jupyter Notebook. We'll go through, do a bunch of different stuff, and if all goes well, I'm sorry, I just plotted the y values, straight line. But they come up with a list of different variables that are in the netcdf file. The only one we really care about here is the radiance value. So if we change that to radiance and rerun it, so that's the value, and we should be able to get a quick and dirty plot. Now, it's really small, right? I mean, in general, it wouldn't go and do this, but you've got access to the data, and I didn't have to do anything. I just clicked on Jupyter Notebook, and this happened. So now that I've got the data, I can go in and, manipulate it or plot it differently or make combinations thereof or whatever. It's basically a route to get you the code you need to access the data, and from there, you're on your own. So it's 25 after. I think that's about all I really had. Any questions? Well, I did want to acknowledge Unidata and just all of the places that we get the data from. Yeah, Unidata, UW-LNS for the Jupyter Hub server, NOAA, NASA, NSF, NCEP, all of the places that this data comes from. Thank you to all of them. So, thanks.
Thank you.
Stefan.
Well, we have a flood of data sets.
Yes.
One could get access still to TDF-11, which was the ship, tropical ocean ship observations with a 1 degree square resolution and with all the outliers were sort of hidden. Then later one noted that they had compacted it into 2 degrees square and kicked out the outliers, and all the precious information was lost. Well,
I would have
regarding
to
the
Google.
dynamics, regarding the solutions, all that sort of thing.
Right, it's,
So the TDF-11 is probably not accessible in this flash.
I'm guessing it's probably not generated anymore. If it's out there, we probably could get it, but I don't know. I'm not familiar with the data set. John?
First, I want to congratulate you. We got two for the guys for the cost of one, 25, 30 years ago. A meteorologist and a IT guy. Is this talk going to be available to people that couldn't attend today?
Yes, we're recording it, and it'll be on, if you go to the AOS webpage and down in the lower right-hand side, there's a Facebook link and a Twitter link and a YouTube link. Click on the YouTube link, and this talk and all of the other seminars and colloquia and other things that weather watches that we've recorded will be available on there. I could send the link out to this talk to everybody if you want. I've gotten requests from a couple of people already.
Why not?
So yeah, it will be available. And of course, I'm available. So, if you saw something on here that looks interesting and you have a question, or, you want to mess around with the data, hit me up and I'll get you connected. John?
Along those lines, Pete, have you taken a census of the data sets that certain research groups might have? And do you know what the landscape is of everybody who's working in the building in terms of what they have? So that we don't do what you said earlier,
Go out and get a bunch
reinventing
of
the wheel.
stuff,
Yeah, go
right.
and getting them.
I sort of vaguely know some data sets that I've found. Probably a lot of the data sets are not complete, although I know you've got a bunch, like the
Ends up reanalysis.
that you've got some, there's some other stuff too. No, I really haven't,
Okay.
and I probably should do that. I know a lot of different groups have pieces of data sets that they were using, but not the whole thing.
Yeah.
The other thing I wanted to mention is on the Threads server, I'm starting to collect archives of various cases. I've got a whole bunch of data for Hurricane Michael. Maria? Michael?
Yeah.
Might be Michael. And I've got a whole bunch of data that I kept from this last, like the snowstorm and the cold outbreak that we had about a week ago. And I need to figure out how to make that data available. I've done that before, where some really interesting weather event will happen, and people will be like, oh, save all the data from this time to this time, and I've got all the data there, and it just sits there, and like 5 years later, I'm like,
Yeah.
why is this taking up space? Nobody ever used
I'm
it.
guilty of that.
I'm thinking if I can get it into the Threads server and it's out there, people will have access to it and know it's there and be able to make use of it. I mean, beyond us even, the Unidata community as a whole. Michael?
Oh, I think Greg had his,
Greg?
Well, the one piece of data that we all would like to have or have access to is UW-AOS.
Ah. How much money do you have?
That's the thing, do they have a deal for education, is there some way we can?
As far as I know, all we can get right now is what's on NOAA port, which is 2.5 degree sea level pressure, 850 temperature, 200 millibar winds. There's a very restricted amount of data. I've contacted the director of the Weather Service, Louis Uccellini. They wrote up a letter to ECNWF saying, could we please have access to the other WMO allowed stuff, which wouldn't be the full data set. It wouldn't be enough to run the model, but it would be better than what we have now. That was September, might have been last summer. We have yet to hear back from him. But he's running for president of the WMO, so maybe we'll get lucky. Maybe it'll be like, hey, I don't know. I think that the answer to that, I think, is we'll probably never be able to take the full resolution ECNWF, or even enough to like initialize a model and put it on a Thread server and make it publicly available. You have to buy it and it's not cheap. Every time I've looked for it. John?
Just a comment in this regard. Historically, there was a long period of time during my lifetime as a meteorologist when much of the global information was not available because of political considerations, like from China,
Yeah,
et cetera, which were just a data void.
Right.
You couldn't do global meteorology back when I was younger. So maybe ECMWF is actually a European conglomerate. It might be there's some political reasons recently that might have meant that it's going to not be as widely available to non-European users like the U.S.
That would be wonderful.
So wait till
If there
Brexit.
was available.
Anybody else? Thank you.
All right,
Yeah.
thanks.
Great.
I don't think I drank my coffee once.
Might be the only hour of your professional life, would that be true?
shaking here.
Europeans.